Good evening. My name is Jesper Gay. I'm working in my 14th experiment, which is a presettable counter. Now I'm going to show you how I wire that counter. This video is a part one of that project because I have two part of that project. This is a video part one. Okay. Okay. This is my breadboard. Um, First, before I do anything in the device, I have to power the board. I have my ground wire that's come from the ground here, connect here. I got the power from 5 volt and connect to here. Because so those light here, see one is got a negative sign, the other one got a positive sign. Those and the same thing in this side too. But this side not connect to that side. So that's why I have the jumper here, and the same thing for this. So I have a jumper here to connect this to this, and I have a jumper here to connect this side to this side to that side, and then same thing here. Okay, so now I power the board. Now when I power the board, I put the device. I have to power the device itself. Uh, First, the first pin of the device is the ground. Not it's not the pin number one, but in this side here, this pin is the ground. I put it connected to the negative line and connect it to that pin. Ground the device, and then I power the device from here, which is this pin up here too. Connected to the positive side, and then going to the pin number one. So now I have power in my device. And now I'm gonna distribute the power and to make this thing count the way I want it to count. Uh, this experiment is a experiment called a presettable counter. That means that's a counter that not gonna start at zero. It's gonna start at some number, and from that number I can count up or count down. But in this case, I'm going to count up. Okay, I have right here. You see, I have in for this side here, I got a bunch of wire connect here. Okay, the first wire is connect to pin. The pin is pin number one. That pin called P1. P1. I connected P1 to a switch. This switch number two. I The pin number two, it's an output. That output connect to a light. But since it's a P, it's a Q. It's called Q number one. Q number one go to light number two. Why it doesn't go to light number one? Since in this board I have in the board here, I have the output start at zero, and since the P start at zero, so now I got Q1, but it's going to light number two because those lights start at zero. So go to light number two, and pin number three is another output. That output is output Q0. It's Q0. That will go to my first light. Let's go to here. That's why we're here. And then I have pin number four. Pin number four is called CPD. That pin is called CPD. The CPD stands for countdown clock pulse. It's countdown clock pulse. That means that's where have to connect my signal. It depends on what the way I want to count. If I want to count down, I will connect it here. If I want to count up, I can connect it somewhere. But now since I'm count up, so now I take this pin, I connect it to high. I connect it to VCC. Connect it. VCC is right there. Connect it to VCC. Now the next pin, which is a pin number five. Pin number five. Now I'm count up. It's the one that count up. Now I connect it to my clock signal. Now I got to the fifth one. The fifth one is It's another output. It's Q2. Connected to output the light number three, and then I have 7, number 7, which is a Q3, another output, because when you hear Q, that's output in this case. So it's going to my last slide, the fourth one. And as I tell you, this one is the ground. I've already explained it. And now when I go to the other side, I go to the other side. This is why we already talk about it. This is the cut down. We put it in CPD. You can put it in high. So VCC. And I have another wire here that jump from here. That's come from on this side, pin number 3, or we say number 14. And that's a MR. MR is master reset. The master reset, when I do the master reset, I connect it at 0. Why? Because the master reset is at low. So I connect it at 0. Right there in the middle, I got a little wire here, a yellow wire that come from pin number 12, which is TCU. The TCU, stand for terminal count up. So I'm counting up. And I take that PCU, I connect it to the load. The load I am using. As I tell you, I'll start from a presetable number, and that's what gonna bring me to where I'm supposed to be. And now the last 2 pin where I have here, which is a pin number 10, P2 that go to switch number 3, and pin number 9. That's white wire. It's a P3 as going to the last switch, switch number 4. Well, this is it for the wiring. As I said earlier, it's a presettable clock. The number, where I'm supposed to start the clock, because I can be any number, but it is a experiment. I have a number to start it. That number is number 6. Which will be 0, because I have a 4-bit counter. The first bit will be 0, and I have the second one 1. Will be low, high, and low. Okay, now I'm going to turn this thing on. I should have my light should start at low, high, low, which is off, on, off. If it starts like that, so it will be a good start. And this counter can count up to 9. So if it's count up to 9 and go back to 0, 1, 1, 0, that means the counter worked properly. So turn it on, then go, yeah. Correct. Yep. Because when you see that, that's where we're going to show. Start here and then move here, go back here. So that means this is 6, 7, 8, 9. 6, 7, 8, 9. Well, I think I did a good job. And so stay tuned. I'll see you in the next video. Because